Good morning everyone. This is Sunil MH, Assistant Professor of Physics in Government First Grade College, Ranebennur. Here I am going to discuss the first session of Theory of Relativity, which is prescribed by Karnataka University, Dharwad in 5th semester, paper 2 of Physics. In this session, we are going to study the introductory part of Special Theory of Relativity and its importance. And you know this man. He is well known for this theory, who brought a new era in physics and created a history in physics, that is none other than Mr. Albert Einstein. So he proposed special theory of relativity in 1915 and general theory of relativity in 1915, but in this session and in your syllabus we have only special theory of relativity that will be discussed here. What are the things we need to learn before going to session are frames of references. You know well known about this thing. You have studied in a first semester frames of references. We cannot say a particle or a body going alone without referring it to something else. We cannot say where it is going, how it is going. For example, we say a vehicle is moving on a road. We cannot say vehicle is moving. So we are saying that vehicle is moving on a road means with a reference to the point, that is a road, with reference to the road the vehicle is moving. We study frames of reference in further slides and dynamics of the system. We studied kinematics. In those things, we studied dynamics, that is force, mass, speed, velocity, acceleration, space, time, simultaneity, mass, etc. These are the very required aspects of physics here to study special theory of relativity. Terms used in relativity, that is especially in special theory of relativity, are space. The space is the boundless three-dimensional extent in which objects and events have relative position and direction. Second one is time. Time is the ongoing sequence of event taking place, or it is a measure of a period where the event taking place. The third, the special thing here is space time, the collaboration of space time. Before the aspect of a theory of relativity, space and time were considered as a two different aspects, but in this thing, means in special theory of relativity, space and time is merged, called space time manifold. Here space time is any mathematical model which fuses three dimension of space and one dimension of time into a single four-dimension manifold. It consists of space consists of three dimensions. If we take Cartesian coordinate, it consists of three axes x, y, z, and we are including another coordinate, that is time. So in those collaborated to give a four-dimensional manifold. The next thing is event. An event is the instantaneous physical situation or occurrence associated with a point in space and time. For example, breaking of a glass when it falls on the floor. It occurs unique place and unique time. And observer. Observer in special theory of relativity, an observer is a frame of reference from which a set of objects or events are being measured. Next thing is frames of references. We are all well known about this thing. A system of coordinate axes which defines the position of the particle in two or three dimensional space is called as a frame of reference. The simple frame of reference is a Cartesian coordinates. We are all well known about Cartesian coordinate, which consists of x, y and z axis, means in 3 dimension. Look at this picture here. Here we have frame of reference 1 and frame of reference 2. Frame of reference 1 is indicated by S frame and frame of reference 2 is indicated as S prime frame. S frame has 3 axes x, y, z and X prime frame has 3 coordinates x prime, y prime and z prime. Here we have a point P. With respect to the S frame, it has coordinates x, y, z and t. Look at this t. Here we have 3 dimension of space. Another dimension of time is included. And other thing, we have the x prime, y prime, z prime and t prime. These are the points are coordinates with respect to S prime frame of point P. So a point P is represented by these with respect to S prime and by these with respect to S prime frame. So here S prime frame is at some distance from S frame and moving with some velocity. Let us see those things in further slides. We have two kinds of frames of references. One is inertial frame of reference and non-inertial frame of reference. What do you mean by inertial frame of reference? Look at this picture here. Here we have two coordinates x, y, z and x prime, y prime and z prime of S prime frame and x, y, z are belongs to S frame. Here it is S prime is at some distance from S frame and moving with some velocity, it is indicated. So any frame of reference which moving with a uniform constant velocity or constant velocity with respect to a frame of reference, then it is called as inertial frame of reference. Look at here. These are unaccelerated frame of reference moving with uniform velocity. A frame of reference which is not accelerating with respect to some other frame. For example, a train is moving with a constant velocity with respect to ground, then it can be, we can say that it is the inertial frame of reference. The second one is non-inertial frame of reference. Look at this picture here. Here we have two coordinate system. One is inertial frame and another one is non-inertial frame. Here we have 3 axes and here also we have 3 axes, but the non-inertial frame is indicated with A. E means accelerated. This frame of reference is accelerated by some magnitude with respect to inertial frame. So we can say that these are the accelerated frames of reference moving with non-uniform relative motion. So inertial frame of reference says that the two frames of reference move with uniform relative motion, whereas in non-inertial frame of reference the two frame of reference are under acceleration. So what is the concept of Newton regarding theory of relativity? A Newtonian principle of relativity. Absolute motion, which is the translation of a body from one absolute place to another absolute place, can never be detected. Translator motion can be perceived only in the form of motion relative to other material bodies. Or simply we can say that the fundamental physical laws and principles are identical in all inertial frame of reference. If a physical law is applied for an inertial frame of reference, the same law can be applied in another frame of reference which is moving with some constant velocity with respect to the first frame of reference. For example, we can say that if you are conducting an experiment in various parts of a spaceship which is at rest, and you are sliding inside the spaceship and conducting so many same experiment in the different parts of the spaceship. You will get same results in all the part of the or all the places of the spaceship. Means the physical laws or we get a same result. So result is unaffected by the position inside the closed spaceship. This is an example for Newtonian principle of relativity. So next we are going to see what are the concepts of Galileo for relativity. To define that, we are going to see transformation equations of Galileo. So look at this picture. Here we have two frames of references, S and S prime. S and S prime. S prime is moving with some velocity V with respect to S frame. So the origin, and here we have a point P which is at a distance x from the origin of the S frame. S and the S frame are having a distance of Vt. Their uh, origins are O and O prime respectively. Here these axes of S prime are X, Y, Z, and axes of S prime frame are X prime, Y prime, and Z prime. The distance of point P from S prime frame origin is X prime. Using this data, we are going to write some equations or transformation equations which are called Galilean transformation equation. Here already it is said that S prime frame is moving with some uniform velocity v with respect to S frame. So we can write, so it is indicated that along the x-axis also we can write the distance x is equal to x prime plus vt, y is equal to y prime, and z is equal to z prime. Here we don't have any other v or t part because we are taking the motion along the x-axis only. So y and z coordinates are unaffected by this movement. So the transformation equation from S to S prime frame, we can write it as x prime, this distance x prime is equal to this distance x minus this distance vt. Call this as equation 1. Y prime is equal to y and z prime is equal to z. So call these as equations as 1, 2, 3 respectively. These equations are called as Galilean transformation equation. We can write their inverse transformation also. Here we have in equation 1 and 2, 1, 2 and 3 we have written x prime in terms of x, y, z, and here in 1a, 2a and 3a we are going to write x, y, z in terms of x prime, y prime and z prime. Means inverse transformation of this one is x is equal to x prime plus vt, 2 is y is equal to y prime, z, and 3 is z is equal to z prime. These are called inverse transformation equations of Galileo. That is 1a, 2a, 3a. So here we need 1, 2, 3 equations which are very important to move in the further slides. So the next thing is invariance of acceleration under Galilean transformation. Look at this thing. We have seen that three equation x prime is equal to x minus vt, y prime is equal to y, z prime is equal to z. Differentiating equation 1, 2, 3 with respect to time, we get velocity, isn't it? When a position is differentiated against velocity, time, we get velocity. The first equation becomes dx prime by dt is equal to dx by dt minus v, or we can write ux prime is equal to ux minus v, where ux indicates velocity of the particle along the x-axis with respect to S prime frame. Ux indicates velocity of the particle along x-axis with respect to S frame minus v. So again, when we differentiate y coordinate, dy prime by dt is equal to dy by dt, or uy prime is equal to uy, and the last one is dz prime by dt is equal to dz by dt, or uz prime is equal to uz. Call this as equation 1, 1c, 2c and 3c. When we differentiate these three equations against time, we get acceleration, isn't it? When a velocity is differentiated against time, we get acceleration. So the respective equations are 1d, 2d and 3d. That says that ax prime is equal to ax, ay prime is equal to ay, az prime is equal to az. These equations are telling us that acceleration are which is measured in both the reference are same, means acceleration is invariant under Galilean transformation. That is, acceleration will be same if we apply a force on a particle. The acceleration with respect to s and s prime frame will be same. So the things which are studied in this session are definitions of space, time, event, observer, etc., which are very required terminologies in special theory of relativity. Frames of references, inertial and non-inertial, Newtonian principle of relativity, Galilean transformation equations and their inverse transformation equations, and invariance of Galilean equations under acceleration. Some of the reference books to study special theory of relativity are here. You can go through it. Thank you all.